Okay, let's move on with our notes so today, and we're going to look at page 63. So pause and get your notes ready if you don't already, or maybe you might like to watch the video through first and then fill them in. We've two examples on this page. So the first one here, we've got a rectangle, PQRS, which is on horizontal ground, and AP is a vertical pole of height 5. So let's fill that right into our diagram there. But that's 5. 5 what? 5 meters. They really should explain what that 5 is, but they didn't, so we don't have to do units in our answers. So it's useful to have something rectangular to visualize this with, and just a pen and a rectangle can help you see where the right angles are going to be. So if you imagine this triangle at the back, APQ, hopefully it's clear that there's a right angle there, and equally APS, there's going to be a right angle down here. Down there. And all of these, of course, are right angles as well, even though they mightn't look like it. Now, these triangles going across the front, ASR, that's not a right angle. So you can imagine if you've got like the front of a pyramid or something. Let me see this clearly. Okay, we've got right angles along the side like this, but if I draw a triangle in the middle of that, that doesn't necessarily have any right angles. Okay, let's look at what they're asking us to do in any case. You know, whenever the question asks for an angle like AQP, they've told you what triangle to use. So the AQ and P of the angle and the AR and P, here is going to tell us what triangle to use, and ASP at the end as well. So all of these, the requested angle tells us what triangle to use. I might make that as a note. Tells us which triangle to use. Now, the first thing we're asked to do is to find the distance AQ. So AQ is this line, this dotted line, going down here. And that's part of this green triangle at the back, which is a right angled triangle. And let's sketch it out for ourselves. We don't need to take up lots of space to do this. P and A. And I know that that's 5 because they told me that already. What else do I know? Well, if this is 3 and that's a rectangle, this is 3 as well. So PQ is 3. Then to find AQ, I'm just going to use Pythagoras' theorem because AQ is the hypotenuse of that triangle. H squared is equal to 3 squared plus 5 squared, which is 9 and 25, which is 34. And H, or AQ, is the square root of 34. And there's no need to simplify that any further. You can check in your calculator, of course. Square root of 34 doesn't simplify. Let's not change it to a decimal. We'll just leave it as a third. So that is the square root of 34. They also want us to find PR. Okay, so PR, it's the diagonal line of the rectangle. So for part 2, I'm going to use this triangle here. I could use this one or this one, they're identical, PSR. PR there, S and R. I know that this distance is 3, and I know that if that's 4 and that's a rectangle, that must be 4 as well. That's a right angle triangle. So by Pythagoras, there's my hypotenuse. H squared is equal to 3 squared plus 4 squared. This is my 3, 4, 5 triangle. The longest side is always the hypotenuse. Anyway, that's 25, and H is equal to 5. No units because there were no units in the question. You can put meters on them if you want to. Part 3 then asks me to find AR, the distance from A to R. So if I join the dotted line that they've described there, this one might be a hard one to visualize, but that is a right angled triangle in there. So when I sketch this out, R, P, A, I have a right angle here at P. P to R, I've just calculated, is 5. A to P, we were already told was 5. So I didn't draw this isosceles, but it is an isosceles triangle. And again, a very quick Pythagoras theorem. H squared is equal to 5 squared plus 5 squared, which is 50. And H is equal to the square root of 50, which does simplify when you put it into your calculator to 5 times the square root of 2. 5 times the square root of 2. I'm not filling them all into the diagram because it can get a little bit messy if I try and do that. Now, we're a little bit low on space here. So let's put in an extra sheet of paper. For part 4, we're calculating some angles. So for part 4, we're asked to find the angle AQP, and that means we need to use the triangle AQP, which we've already drawn up here, AQP, and they want us to find the angle there at Q. But I'm going to sketch it out again. AQP. 5, 3, square root of 34, and we want to find this angle in here. We're looking for an angle and we have sides in a right angled triangle. It means SOHCAHTOA. Which should we use? Sine, cos, or tan? Well, we have all three. We have the hypotenuse, we have the adjacent, and we have the opposite. It doesn't matter. I'm just going to use tan because we've been using it a lot, so it's probably fresh in our minds. I could use sine and I could use cosine. So any of the three ratios will work here because we have all three sides. Tan of Q is the opposite over the adjacent. So Q is tan inverse of 5/3. And we'll go to 2 decimal places because they didn't specify. Tan inverse of 5/3. 59.04. 59.04 degrees. Okay, that's the answer to part 4. Part 5, we're asked for the angle ARP. And again, they've told us what triangle we're using, ARP. It's the purple triangle that I drew here. And they want me to find the angle at R. So they're asking for this angle here. You can use your existing diagram. Just as we're doing the notes, I'm going to sketch it out again. I have a right angle there at P. And PR is 5. Again, I didn't draw it isosceles. I won't be penalised for that. The hypotenuse is 5√2. And I want to find this angle in here. Looking for an angle, and I have sides, means SOHCAHTOA. Again, I'm going to use tan. I'll get exactly the same answer if I use sine or cosine, and I'll leave it up to you to verify that for yourselves. So tan of the angle is the opposite over the adjacent, and R is tan inverse of 1. This is one of our special angles, so you should know this one. It's 45 degrees. Exactly 45 degrees. Any right-angled isosceles triangle will always have 45 and 45 down here. Part 6, I want to find the angle ASP. Now, this isn't a triangle that we've drawn out before, is it? ASP. It's the back triangle here. This is the triangle we're talking about. So that's a right-angled triangle as well. P, A, and S, and they want us to find, I apologise, I'm moving that out of shot. They want us to find the angle down here at S. So what do I know? Well, I know that SP is 4, because opposite sides of the rectangle. I know that AP is 5, because they told us that. And I don't know AS, and it doesn't matter, because 2 sides is enough using tan to find that angle. So S is going to be, tan of S is going to be the opposite over the adjacent. Tan of S is the opposite over the adjacent, and S is tan inverse of 5 over 4. We'll go to 2 decimal places. Tan inverse 5 over 4. 51.34 degrees. 51.34 degrees. Okay, so if you're trying to fit this in the notes, you don't have to do these 2 triangles out twice, because you can just use your existing triangles there, or put in an extra page. There isn't a whole lot of space for doing this out in a way that might help you best to study, so you can put in an extra page or some sticky notes to help you with that. Right, let's move on to example 4 then. C, D and B are points on a horizontal ground. Okay, so this beige triangle at the bottom here is on the flat ground, which means that this is a right angle. I've got a tower that's 91 meters tall, and the angle of elevation of the tower is 32 degrees. Calculate BC. So we want to find this distance here. Let's sketch out the triangle on its own. B, A, C, that's 32 degrees in there, that's 91, and this is the thing that I'm looking for. So I have an angle, and I have one side and I'm looking for the other. That means I'm going to use SOHCAHTOA, because it's a right angle triangle. Opposite and adjacent means I'm using tan. So tan of 32 degrees is equal to the opposite over the adjacent. The unknown is on the bottom, so I divide. X is going to be 91 divided by tan of 32. (91) divided by tan of 32, and that is 145.63. Again, they didn't specify a number of decimal places, so we'll just go to 2. 145.63. They did give me units though, so I'll fill those in. 145.63 meters. So this distance here is 145.63. Calculate CD. Okay, this distance here. Now, this is interesting because this triangle on the ground is not a right-angled triangle. Or at least we certainly can't assume that it is. D, B. That angle in there, however, is 49. And we know This distance here is 235 because it's on my diagram. And CB, we've just calculated, is 145.63. Not a right angle triangle, so that means it's either the sine rule or the cosine rule. Oh, which is it going to be, sine rule or cosine rule? I'll tell you that it is going to be the cosine rule, because if I tried to use the sine rule, it just wouldn't work out. The angle that I'm given is between the two known sides. So I want to find this distance here, CD. So the not right angle triangle means it's the sine or the cosine rule. And we're going to use the cosine rule. So my cosine rule for a missing side is that a squared is equal to b squared plus c squared minus 2bc cos a, where a is the angle that I'm given and little a is the side across from that angle. Now, this is just 2 steps, filling it in and then calculating it and getting the square root. So a squared, or x squared in this case, that's what I filled in. I'll try and match it. Is going to be, doesn't matter which one of these is B and which one is C. Let's call that B and that's C. It doesn't matter at all. 145.63 squared plus 235 squared minus 2bc 235 by cosine of the angle in between, by cosine of 49. Sorry, that is a bit squashed there. So the side I'm looking for squared will be that. Let's just type that into our calculator in one go. That's 145.63 squared plus 235 squared minus 2 bracket 145.63 bracket 235 cosine of 49. And that is 31,000, so x squared is 31,528.415, and x is going to be the square root of that. You don't need to write it out again, but you do need to type it into your calculator. 31,528.415, and that gives us 177.56 meters, and that's the distance from C to D. I don't have to relabel it CD. Finding the answer is enough because I labelled it as X on my diagram. Okay, so that's it. Now for homework tonight, I'd like you to do some more practice, another 2 3-dimensional problems. So page 122, questions 6 and 7. Of course, I'll put that up in Google Classroom, and I'll correct it in a video tomorrow, and let me know if you have any questions or if something's not clear. Okay, thank you very much.